Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. In this session, we are going to discuss physics questions from NEET paper 2020 and we are 45 questions. So let's get started. The first question is from the chapter Mechanical Properties of Solids and the question is a wire of length L, area of cross section A is hanging from a fixed support. The length of the wire changes to L1 when mass m is suspended from its free end. So the expression for Young's modulus is, okay. So for Young's modulus, we need two quantities, that means stress and strain, okay. So first we'll find out the stress, that is equal to force divided by area, okay. So force in this case will be equal to mass into acceleration due to gravity and area of cross section is given as capital A. So this is the strain. Now we'll find out the strain. Strain will be equal to change in length divided by initial length, okay. So change in length is what? Final length minus initial length. So final length is L1 according to this question minus initial length is capital L and divided by initial length, okay. So this is the strain. Now we can easily find the Young's modulus, okay. So this is equal to stress divided by strain. So we'll put the values of these two quantities here that we have just found out. So stress is what? Mg divided by A and strain is L1 minus L by L. So this is in division. So we'll write L divided by L1 minus L. Okay. So we can write it here MgL divided by A L1 minus L. So out of the given options, which is the correct option? Option C is the correct answer. Okay. Now question number 2 is from the chapter Kinetic Theory and the question is a cylinder contains hydrogen gas at pressure of 249 kilopascal and temperature 27 degrees Celsius. Its density is, so we have to find out the density. The gas constant is already mentioned. Okay. Now we know that for an ideal gas we use the equation PV equals to nRT. Here P is the pressure, V is the volume, N is the number of moles, R is the gas constant and T is the temperature. Okay. Also we know that number of moles is equal to given mass by molecular mass. Okay. So in place of number of moles we can write small m divided by capital M. Okay. Capital M is the molecular mass. Right. Now we can bring the molecular mass to the left hand side and volume to the right side. Okay. So we can write it like this, pressure into molecular mass equals to given mass by volume into R into T. Okay. So from here we also know that mass by volume is equal to density, right? So we can put this value because we have to determine the density, right? So P into M is equal to density into R into T. Now we have to determine the density. That means density will be equal to P into M divided by R into T. Now we can simply put the values here. Pressure is given as 249 kilopascal. So we will write in Pascal or Newton per meter square. So we will write 249 into 10 to the power 3 Pascal. Okay. Into molecular mass. So we know that the molecular mass of hydrogen is 2 grams. Okay. So if we have to write in kg, that will be equal to 2 into 10 to the power minus 3 kg, right? So let's put this value 2 into 10 to the power minus 3 kg. Okay. Now divided by R into T. So R is given as 8.3 joule per mole per Kelvin. So 8.3 and temperature is 27 degrees Celsius. Now 27 degrees Celsius equals to what? 27 plus 273 Kelvin. That means 300 Kelvin. Okay, so we have to put the temperature in terms of Kelvin. So 300. Okay, now when we'll solve this, we'll get the answer 0.2 kg per meter cube. Okay, so this is the answer. That means out of the given options, option A will be the correct answer. Okay. Question number 3 is from the chapter Dual Nature of Radiation and Matter and the question is Light with an average flux of 20 Weber per centimeter square falls on a non-reflecting surface at normal incidence having surface area 20 centimeters square. The energy received by the surface during the time span of 1 minute is. Okay, so we have to find out the energy and the time given is 1 minute, that means 60 seconds. Okay, so here we will simply use the formula to find out the energy received, and that is equal to intensity into area into the time. Okay, so intensity is the average flux, that means 20 Weber per centimeter square. So it is equal to 20, then area is also 20 centimeter square, so 20 again, and time is 60 seconds, so we'll write 60, and the unit for energy will be joule. Okay, so on solving this, we'll get 24 into 10 to the power 3 joule. Okay, so out of the given options, option B will be the correct answer. Now question number 4 is from the chapter Laws of Motion, and the question is two bodies of mass 4 kg and 6 kg are tied to the ends of a massless string. The string passes over a pulley which is frictionless. The figure is given here and it is asked that the acceleration of the system in terms of acceleration due to gravity is. Okay, so we have to find the value of A in terms of G. Now we can see here M1 is 4 kg and M2 is 6 kg. Okay, in the first case, that means in 4 kg, we can see the tension in the string is greater than the weight. Okay, so here T is greater than mg, whereas in the second case, mg is greater than T. That means T is less than mg. Okay, now we can write the force balancing equation for each one of them. Okay, so let's write for the first one. For 4 kg mass, tension minus mg will be equal to mass into acceleration. So on putting the values, we'll get T minus mass is 4, so 4g equals to 4a. Okay, so tension will be equal to what? 4a plus 4g. Suppose this is equation 1. Similarly, we can write the force balancing equation for the other mass, that means 6 kg mass. Here mg is greater, so mg minus T will be equal to ma. Putting the values, we'll write 6g minus T equals to 6a. So tension will be equal to 6g minus 6a. Okay, so this is equation 2. Now we know the tension in the string will remain same. So this equation, that means 4a plus 4g will be equal to second equation, that is 6g minus 6a. Okay, so 4a plus 4g equals to 6g minus 6a. Now we'll bring all the g together and a together. Okay, so here 4a plus 6a will be equal to 6g minus 4g, right? So 4 plus 6, 10. So 10a equals to 2g. Now we have to find the value of a in terms of g, right? So a will be equal to what? 2g by 10. That means g by 5, right? So out of the given options, which one will be correct? Option B will be the correct answer. Question number 5 is from the chapter Kinetic Theory, and the question is the mean free path for a gas with molecular diameter small d and number density small n can be expressed as. Okay, so this is direct formula based question. You have to remember the formula for mean free path, that is written as lambda, and that is equal to 1 by root 2 n pi d square, where small d is the diameter and n is the number density. Okay, so out of the given options, option A will be the correct answer. Question number 6 is from motion in a straight line, and the question is a ball is thrown vertically downward with a velocity of 20 meter per second from the top of a tower. It hits the ground after some time with a velocity of 80 meter per second. The height of the tower is, okay, acceleration due to gravity is given as 10 meter per second square, and what else is given? Initial velocity u is given as 20 meter per second and final velocity v is given as 80 meter per second. We have to determine height h of the tower. Okay, so we can simply use the equation v square equals to u square plus 2gh, right? So V square minus U square will be equal to 2gh. Now we have to determine the value of h. So h will be equal to V square minus U square divided by 2 into g. Okay. Now we can put the values. V is given as 80 meter per second. So 80 square minus U is 20. So 20 square divided by 2 into acceleration due to gravity is given as 10. Okay. So 80 square is equal to 6400, 20 square equals to 400 and 2 into 10 that means 20. Okay. So here we'll get 300 meter. Okay. So out of the given options, option C will be the correct answer. Question number 7 is from the chapter Current Electricity, and the question is the color code of a resistance is given below. So here yellow, violet, brown and gold colors are mentioned, and it is asked that the values of resistance and tolerance respectively are. Okay, so how do we write the resistance? First two color codes are written as first two digits, then the third color code is written as power of 10. Okay, so the first three colors give us the resistance. Okay, and how do we find the tolerance? Tolerance is separated from resistance by a plus minus sign and it is written as percentage. Okay, so the last color give us the tolerance. Okay, so let's mention the resistance first. First color is yellow, so the code for yellow is 4, so the first digit will be 4. Then the next is violet. Violet has color code 7, so the second digit will be 7. And the third is brown, it has a color code 1, so it will be written as 10 to the power 1. Okay, so it is equal to 47 into 10, that means 470 ohm, right? Now tolerance is gold color, so the color code for gold is what? 5%. Okay, so it will be 5. That means option C will be the correct answer. 470 ohm is the resistance and 5% is the tolerance. Question number 8 is from the chapter Nuclei, and the question is when a uranium isotope is bombarded with a neutron, it generates krypton, then 3 neutrons and what else? That means we have to find out another product. Now let's write down the reaction first. We have a uranium isotope with atomic number 92 and mass number 235. It is bombarded with a neutron, so its atomic number will be 0 and mass number will be 1. What are the products obtained? First product is krypton with atomic number 36 and mass number 89. Then 3 neutrons are obtained, again 0 and 1, and one more element, say element X. Okay, and suppose this element X has atomic number Z and mass number A. Okay, so here we can use the law of conservation of charge and mass to find out the Z and A. Okay, so let's use the law of conservation of charge first. Okay, now here charge denotes the number of electrons or protons. Okay, that means the atomic numbers. So atomic numbers on the reactant side will be equal to the total atomic number on the product side. So this side we have uranium with atomic number 92. So 92 plus the atomic number of neutron is 1, sorry 0. So 92 plus 0 will be equal to 36, that is the atomic number of krypton, plus 0 plus the atomic number of element X, that means Z. Okay, so let's equate this. 92 minus 36 will be equal to Z. Okay, so on solving it, we'll get the value of Z as 56. Okay, so the element will have atomic number 56. Similarly, we can use the law of conservation of mass to find out the mass number. Okay, so here total mass number on the reactant side, that means 235 plus 1 will be equal to the total mass number on the product side, that means 89 for krypton. Then 3 neutrons are there, so 3 into 1, that means 3. Then element X has mass number A. Okay, so let's equate this. 235 plus 1, that means 236, equals to 89 plus 3, that means 92, plus A. Okay, so here we can find out A, that is equal to 236 minus 92, so it will be equal to 144. Okay, so out of the given options, option D will be the correct answer because barium has atomic number 56 and mass number 144. Okay, as given in the option. So this option will be the correct. Question number 9 is from the chapter Electric Charges and Fields, and the question is, a spherical conductor of radius 10 centimeter has a charge of 3.2 into 10 to the power minus 7 coulomb distributed uniformly. What is the magnitude of electric field at a point 15 centimeter from the center of the sphere? Okay, so we have a sphere with radius 10 centimeter, but radius is not important here. What is important? This distance, 15 centimeter. So this distance is from the center to the point at which we have to find out the electric field. Okay, so 15 centimeter means 15 into 10 to the power minus 2 meter. Okay, so we'll put the value in meter. Now the expression for electric field outside a conducting sphere is E equals to 1 by 4 pi epsilon naught Q by R square. So Q is the charge and R is this distance of this point from the center. Okay. So let's put the values. 1 by 4 pi epsilon naught is already given in the question. 9 into 10 to the power 9. Okay. So 9 into 10 to the power 9 into charge is 3.2 into 10 to the power minus 7. Okay, divided by distance square. So this is 15 into 10 to the power minus 2 square. Okay, so let's find the square of 15 into 10 to the power minus 2. So the numerator will be written as it is and denominator will be 225 into 10 to the power minus 4, right? Now on solving this, we'll get 0.128 into 10 to the power 6, and we can write it like this, 1.2 into 10 to the power 5. Okay, and the unit for electric field is Newton per coulomb because electric field is equal to force divided by charge. Okay, so out of the given options, option A will be the correct answer. Question number 10 is from the chapter Ray Optics and Optical Instruments, and the question is, a ray is incident at an angle of incidence I on one surface of a small angle prism with angle of prism A and emerges normally from the opposite surface. If the refractive index of the material of the prism is mu, then the angle of incidence is nearly equal to. So we have to determine the angle of incidence, right? So let's draw the prism first. Suppose this is our prism and these are two normals to the surfaces. Okay, now what happens in prism? A ray of light is incident on one of the surfaces, then it gets refracted from here and strikes the opposite surface and again gets refracted from there, right? That means the same ray of light gets refracted twice. So here the angle formed between the normal and the incident ray is equal to the angle of incidence, so it is given as I. Okay, so this is one of the angles. Then the angle formed between the emergent ray and the normal will be the first angle of refraction, that means R1. Similarly, the angle formed between the second emergent ray and the normal will be R2. So here it is given that it emerges normally from the opposite side. That means it coincides with the normal. So the angle formed between the normal and the emergent ray will be 0 here. That means R2 will be equal to 0. Okay. Now we know that in a prism, R1 plus R2 is equal to the angle of incidence A. Okay. So we know that R2 is 0. So R1 plus 0 is equal to A. So we can say that R1 is equal to A. Okay. Now we'll use the Snell's law on the first surface, that means surface AB. Okay, so here mu1 into sine I will be equal to mu2 into sine R1. Okay, so mu1 is the refractive index of the first medium, that means air. So for air the refractive index is 1. Okay, so let's put the value 1 into sine I will be equal to mu2, that means the refractive index of the prism, that is given as mu, into sine R1. So here we have found that R1 is equal to A, so we can put A here. Okay, That means sine I is equal to mu into sine A. Now it is also given that it is a small angle prism. So for small angle prism, we can simply write I is equal to mu into A. Okay. So we have got the angle of incidence. So out of the given options, option B will be the correct answer. Question number 11 is from the chapter Thermodynamics, and the question is, two cylinders A and B of equal capacity are connected to each other via a stopcock. A contains an ideal gas at standard temperature and pressure. B is completely evacuated. The entire system is thermally insulated. The stopcock is suddenly opened. The process is. Okay. So the most important words to note here are thermally insulated. It means that no heat exchange will take place. Okay, and we know that a process in which there is no exchange of heat between the system and the surrounding is known as adiabatic process. Okay, so the correct answer will be adiabatic, that means option A. Question number 12 is from the chapter Magnetism and Matter, and the question is, an iron rod of susceptibility 599 is subjected to a magnetizing field of 1200 ampere per meter. The permeability of the material of the rod is. Okay, so the permeability is denoted by mu. Now here absolute permeability mu naught is given as 4 pi into 10 to the power minus 7 Tesla meter per ampere. Okay. Now first of all, we know the susceptibility is 599. So with the help of susceptibility, we can find out the relative permeability, that means mu r. Okay, it is equal to 1 plus susceptibility. So that will be equal to 1 plus 599, that means 600. Okay, now we have got the relative permeability, so we can find out the permeability of the material, that is equal to the product of absolute permeability and relative permeability. Okay, so absolute permeability is given in the question, it is equal to 4 pi into 10 to the power minus 7, and relative permeability is 600. Okay, so on multiplying this, we'll get 2400 pi into 10 to the power minus 7. So it can be written as 2.4 pi into 10 to the power minus 4, and the unit will be Tesla meter per ampere. Okay, so out of the given options, option D will be the correct answer. Question number 13 is from the chapter Nuclei, and the question is, the energy equivalent of 0.5 gram of a substance is. Okay, so this is simply based on mass, energy, equivalence. Okay, according to this, the energy is equal to the product of mass and c square. C is the speed of light in vacuum. Okay, so mass is given as 0.5. So 0.5 into 10 to the power minus 3, because this is given in gram and we will write in kg. Okay, so 0.5 into 10 to the power minus 3 kg into speed of light in vacuum is 3 into 10 to the power 8 meter per second. So square of this. Okay, now on solving this, we'll get 4.5 into 10 to the power 13, and the unit for energy will be joule. Okay, so out of the given options, option A will be the most suitable answer. Question number 14 is from the chapter Electrostatic Potential and Capacitance, and the question is, a 40 microfarad capacitor is connected to a 200 volt 50 Hz AC supply. The RMS value of the current in the circuit is nearly. Okay, so we have to find out the value of IRMS, right? Now RMS voltage, that means ERMS is given as 200 volt and frequency is given as 50 Hertz. So we can find out the omega. Omega is equal to 2 pi f. That is equal to 2 into pi into frequency is 50 Hertz, right? So it will come out to be 100 pi. So now we have got the omega, and capacitance is given as 40 microfarad. That means 40 into 10 to the power minus 6 farad. Okay. Now we have to find out the IRMS. So there is a simple formula for this. IRMS is equal to C into omega into ERMS. Okay. So we have got the values of all three. Capacitance is 40 into 10 to the power minus 6. Omega is equal to 100 pi, and ERMS is given as 200 volt, right? So on solving this, we'll get 2.5, and the unit of I, that means current, is ampere. So 2.5 ampere, that means option B is the correct answer. Question number 15 is from the chapter Electromagnetic Waves, and the question is the ratio of contributions made by electric field and magnetic field components to the intensity of an electromagnetic wave is. Okay, C is the speed of electromagnetic wave. Okay, so suppose this is the electric field and this is the magnetic field. Both are perpendicular to each other, and the direction of the electromagnetic wave is this. Okay, so here half of the intensity to this wave is provided by the electric field and half is provided by the magnetic field. Therefore, their contributions will be 1:1. Okay, so option A will be the correct answer. Question number 16 is from the chapter Systems of Particles and Rotational Motion, and the question is two particles of mass 5 kg and 10 kg respectively are attached to the two ends of a rigid rod of length 1 meter with negligible mass. The center of mass of the system from the 5 kg particle is nearly at a distance of. Okay, so we take two axes here, one is x axis and the other is y axis. So we are taking 5 kg as reference, right? So in this type of question, we assume one of the masses to be kept at the origin. So here it will be 5 kg mass that is kept at the origin. Okay. Then the 10 kg mass will be kept at a distance 1 meter. That means 100 centimeter. Because all the options are given in centimeter, so we'll consider the centimeter unit. Okay. So here we have M1 as 5 kg. And x1 will be 0 because it is kept at the origin. Similarly, m2 is 10 kg and x2 will be equal to 100 centimeter. Okay, so x2 is 100. Now we can find out the center of mass using the formula m1 into x1 plus m2 into x2 divided by the sum of masses, that means m1 plus m2. Okay, so m1 is 5, x1 is 0, plus m2 is 10 and x2 is 100, right? Divided by m1 plus m2, that means 5 plus 15. So on solving this, we'll get 200 divided by 3, that will be equal to 66.66 centimeter. So it will be approximately equal to 67 centimeter. So out of the given options, option B will be the correct answer. Question number 17 is from the chapter Current Electricity, and the question is a resistance wire connected in the left gap of a meter bridge balances a 10 ohm resistance in the right gap at a point which divides the bridge wire in the ratio 3:2. If the length of the resistance wire is 1.5 meter, then the length of 1 ohm of the resistance wire is. Okay, so let's draw the meter bridge first. Here we have the battery. Then we have the switch, and then here we have two resistances, suppose P and Q. So P is on the left side, Q is on the right side. So according to the question, the resistance on the right side is 10 ohm. That means Q is given as 10 ohm. Okay. Also it is given that the length of the bridge wire is in the ratio 3:2. That means if this is L1 and this is L2, then L1 by L2 is equal to 3/2. Okay. Now, initially P by Q will be equal to L1 by L2. Okay. So, P by Q, that means 10 ohm. It is already given. And L1 by L2 is also given. It is 3/2. Okay. So what will be the value of P? It will be equal to 10 into 3/2. That means 30/2. So it will come out to be 15 ohm. Okay. So now we have got the value of P as well. Now focus on the last line of the question. If the length of the resistance wire is 1.5 meter, that means the wire related to this 15 ohm resistance. Okay, so if this is R1, then the length associated with this resistance will be L1. Okay, and we know that R is directly proportional to L. Okay, you know the formula, R is equal to rho L by A. So R is proportional to L. That means R1 by R2 will be equal to L1 by L2. So R1 is 15 ohm and L1 is 1.5 meter, right? Similarly, R2 is 1 ohm. It is given in the question. So 1, and we have to determine the L2. Okay. So we'll solve this. We'll get 15 L2 equals to 1.5. So L2 will be equal to 1.5 divided by 15. That means 0.1 meter. Okay. So this will be written as 1 into 10 to the power minus 1 meter, right? So out of the given options, which option will be correct? Option A. Okay. Question number 18 is from the chapter Wave Optics, and the question is, in Young's double slit experiment, if the separation between the coherent sources is halved and the distance of the screen from the coherent sources is doubled, then the fringe width becomes. Okay. So we have two coherent sources, S1 and S2. Okay, we know that the distance between the coherent sources is denoted by small d, and the distance between the coherent sources and the screen is denoted by capital D. Okay, so here the new separation distance, that means d dash, is halved, that means it becomes d by 2, and the capital D is doubled, that means it becomes 2d. Okay, now we know that the fringe width is denoted by beta. So fringe width will be equal to lambda into capital D by small d. This is the formula to find the fringe width. Now new fringe width will be what? Lambda into 2d, because capital D has been doubled, and divided by small d by 2, because small d has been halved. Okay, so it will be equal to 4 lambda d by small d. Okay, so we know lambda d by d is beta, that means initial fringe width, so it is 4 times the initial fringe width. Okay, so it will be option B, that is the correct answer. Okay. Question number 19 is from the chapter Current Electricity, and the question is, a charged particle having drift velocity of 7.5 into 10 to the power minus 4 meter per second in an electric field of 3 into 10 to the power minus 10 volt per meter has a mobility in meter square per volt per second of. Okay, so we have to determine the mobility of the charged particle. Okay, mobility is denoted by mu, and it is equal to the drift velocity per unit electric field. Okay, so we can put the values because both drift velocity and electric fields are mentioned in the question. So drift velocity is 7.5 into 10 to the power minus 4 meter per second, and the electric field is 3 into 10 to the power minus 10 volt per meter. Okay, so on solving this, we'll get 2.5 into 10 to the power 6, and the unit will be meter square per volt per second. Okay, so out of the given options, option A will be the correct answer. Question number 20 is from the mechanical properties of solids, and the question is, dimensions of stress are. Okay, so what is stress? Stress is equal to force per unit area, right? So the dimension for force will be what? We know that force is equal to mass into acceleration due to gravity. So the dimension for mass will be m, and for acceleration due to gravity it will be LT minus 2. So the dimension for force will be MLT minus 2. Okay, and the dimension of area is L square. So what will be the dimension of stress? M L 1 minus 2 and T minus 2. Okay, so it will be equal to M L minus 1 T minus 2. Okay, so out of the given options, option C will be the correct answer. Question number 21 is from the chapter Atoms, and the question is, for which one of the following Bohr model is not valid? So here we should know that the Bohr model is valid only for single electron species. That means species having one electron only. Okay, so let's check the number of electrons in the given options. First one is singly ionized helium atom. Okay, so we know that the atomic number of helium is 2. That means the number of electrons will be 2, right? Now after one ionization, one electron will be removed, so only one electron will be left. Okay, that means the Bohr model will be valid for this species. Okay, now we come to the second one. Here we have deuteron atom, that means H12. Okay, we know that hydrogen has three isotopes, H11, H12 and H13. Now in all of them, the atomic number or the number of electrons remains same, that is 1. Okay, only the mass number varies, so number of electron will be 1 only in deuteron as well. So the Bohr model will be valid for this as well. Okay, now we come to the third one. It is singly ionized neon. Okay, so Ne plus. What is the atomic number of neon? It is 10. That means the number of electron will be 10. Now how many will be left after one ionization? 9 electron will be left. Okay, so Bohr model will not be valid for this because it does not have one electron. Okay, so this will be the correct choice here. Let's have a look at the last one as well. It is hydrogen atom. So we know that the hydrogen atom has only one electron. Okay, so valid for this also. Only option C will be the correct answer. Question number 22 is from the chapter Alternating Current, and the question is, a series LCR circuit is connected to an AC voltage source. When L is removed from the circuit, the phase difference between the current and voltage is pi by 3. Now if instead C is removed from the circuit, then the phase difference is again pi by 3 between current and voltage. So the power factor of the circuit is, okay, so let's draw the circuit first. We have an inductor, then we have a capacitor, and then we have a resistor, right? This is the power source. Now here we will have XL, that means inductive reactance. Here we will have XC, that means capacitive reactance, and here we will have resistance. Okay, now in the first case L is removed. Okay, so when L is removed, that means the inductor is removed, then what will be the value of tan theta? Here we know that theta is equal to pi by 3, right? So tan pi by 3 will be equal to xc by r. Okay, so this is the first equation. Now in the second case, c is removed. So when c is removed, what will be the value of tan theta? Tan pi by 3 will be equal to xl by r. Okay, so this is the second equation. Now theta is same, so tan theta will also be same. That means xc by r will be equal to xl by r. Okay, r is same, so we can say that xc is equal to xl. Okay, now how can we find the impedance? Impedance is denoted as capital Z, right? And that is equal to under root r square plus xl minus xc square. Okay, so here we know that xc is equal to xl. That means xl minus xc will be equal to 0, right? So this part will be 0. That means impedance will be equal to resistance. Okay, now we have to find out the power factor, right? So power factor, that means cos theta will be equal to r by z. So r and z are same, that means it will be equal to 1. Okay, so out of the given options, option B will be the correct answer. Question number 23 is from the chapter Mechanical Properties of Fluids, and the question is, a capillary tube of radius r is immersed in water and water rises in it to a height h. The mass of the water in the capillary is 5 grams. Then another capillary tube of radius 2r is immersed in water. the mass of the water that will rise in this tube is. Okay, so suppose M1 is 5 kg, then we have to find out the M2, right? R1 is given as R and R2 is given as 2R. Now we know that force of surface tension balances the weight of water in the capillary tube. Okay, so force will be equal to mass into acceleration due to gravity, that means weight of the water. Okay, now the value of force of surface tension is 2 pi r T cos theta. So T is the surface tension. Okay, that is equal to mass into acceleration due to gravity. So here we can see that the radius of the capillary tube R is directly proportional to the mass of water. Okay, so R is proportional to mass. That means R2 by R1 will be equal to M2 by M1. Okay, now R2 is given as 2R, R1 is R, M2 has to be determined, and M1 is given as 5 grams. Okay, so here we can easily find M2, that will be equal to 2 into 5 grams, that is 10 grams. Okay, so option B will be the correct answer. Question number 24 is from the chapter Ray Optics and Optical Instruments, and the question is, assume that the light of wavelength 600 nanometer is coming from a star. The limit of resolution of telescope whose objective has a diameter of 2 meter is. Okay, so D is 2 meter, lambda is 600 nanometer, and we have to find out the limit of resolution, that means theta r. Okay, so what is the formula to find out the limit of resolution? It is equal to 1.22 into lambda by d. Okay, so lambda is the wavelength and d is the diameter. So let's put the values here. 1.22 into lambda is 600 nanometer, that means 600 into 10 to the power minus 9 meter, right? Divided by small d, that is diameter, and it is given as 2 meter. So on solving this, we'll get 3.66 into 10 to the power minus 7, and the unit for the limit of resolution will be radian. So the correct option will be option D. Okay. Question number 25 is from the chapter Current Electricity, and the question is, the solids which have the negative temperature coefficient of resistance are, options are insulators only, semiconductors only, insulators and semiconductors, and the last one is metals. Okay, so what is meant by negative temperature coefficient of resistance? It means that the resistance of the material decreases with the increase in temperature. Okay, that means as temperature increases, the resistance will decrease. Okay, whereas in case of positive temperature coefficient of resistance, the resistance increase with increase in temperature. Okay, so as T increases, resistance also increases. Okay, now positive temperature coefficient of resistance is related to the conductors or metals. Okay, whereas negative is related to both insulators and semiconductors. So option C will be the correct answer. Okay, let's have a look at the graph. This is your temperature, and this side we have resistance. Okay, so for conductor the graph will be like this because the resistance will go on increasing with increase in temperature. Okay, so this is for metals, whereas for insulators it will decrease. Similarly for semiconductors as well, it will decrease. Okay, therefore we say that semiconductors and insulators have negative temperature coefficient of resistance. Got it? Alright, now question number 26 is from the chapter Electrostatic Potential and Capacitance, and the question is, the capacitance of a parallel plate capacitor with air as medium is 6 microfarad. With the introduction of a dielectric medium, the capacitance becomes 30 microfarad. The permittivity of the medium is, okay, so we have to find out the permittivity of the medium. The absolute permittivity is given as 8.85 into 10 to the power minus 12 Coulomb square per Newton per meter square. Okay. Now, we know that the capacitance with dielectric medium will be proportional to the capacitance with air as medium. Okay. that is C naught. So we can write that the capacitance with dielectric medium is equal to the constant K into C naught. Okay, so C naught is the capacitance with air as medium. Okay, so what will be the value of K? K will be equal to C divided by C naught. So we can say that K is the ratio of capacitance with dielectric medium to the capacitance with air as medium. So what is the capacitance with dielectric medium? It is 30 microfarad, right? So 30 divided by the capacitance with air as medium is 6 microfarad. So 6. So here we'll get 5. Okay. So the value of K is 5. Now at the same time K is also the ratio of permittivity of medium to the absolute permittivity. Okay. And we know that K is equal to 5. So 5 equals to permittivity of the medium divided by absolute permittivity. Now the value of absolute permittivity is also given in the question. So what will be the value of permittivity of the medium? It will be equal to 5 times the absolute permittivity. That means 5 into 8.85 into 10 to the power minus 12. Okay. So on solving this, we'll get 0.44 into 10 to the power minus 10 coulomb square per Newton per meter square. Okay. So option B will be the correct answer. Question number 27 is from the chapter Work, Energy and Power, and the question is the energy required to break one bond in DNA is 10 to the power minus 20 joule. This value in electron volt is nearly. Okay, so here we simply need the relation between electron volt and joule. So remember that 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. Okay, so we can write that 1 joule is equal to 1 divided by 1.6 into 10 to the power minus 19 electron volt, isn't it? So we need the value of 10 to the power minus 20 joule in electron volt. So 10 to the power minus 20 joule will be equal to 10 to the power minus 20 by 1.6 into 10 to the power minus 19 electron volt. Okay, so here on solving this we'll get 0.06 electron volt. That means option B will be the correct answer. Question number 28 is from the chapter Semiconductor Electronics, and the question is the increase in the width of the depletion region in a PN junction diode is due to options are reverse bias only, both forward bias and reverse bias, increase in forward current and forward bias only. So the correct option is option A, that means reverse bias only. Okay. So let's see what happens in the case of reverse bias. So we have two sides here, N side and P side. So on the P side, the majority charge carriers will be holes, right? Similarly, on the N side, the majority charge carriers will be electron. And this is the junction. So in the junction, the minority charge carriers reside. That means electron of P side and holes of N side will reside in the junction. And this region is known as depletion layer. Okay, or depletion region. Now, in case of reverse bias, the P side is connected to the negative terminal of the battery, right? Whereas the N side is connected to the positive terminal of the battery. So what will happen? This negative terminal will attract the majority carriers of P side, that means holes. Okay, so let's write it down. Negative terminal will attract holes from P side. Okay. Similarly, the positive terminal will attract electrons from the N side, right? So what will happen? This, due to this, the majority carriers move away from the junction, right? So when these will move away from the junction, then the width of this depletion layer will increase, right? So due to this, the width of depletion region will increase. Okay. Therefore, option A will be the correct answer. Now, what will happen in case of forward bias? The opposite will happen. Okay, that means this side we will have positive. Okay, so the positive will repel the holes and the negative this side will repel the electrons. So the majority charge carriers will move towards the junction, and due to that the width of the junction will reduce. Okay, but here the width will increase because of reverse bias. Question number 29 is from thermal properties of matter, and the question is the quantities of heat required to raise the temperature of two solid copper spheres of radii R1 and R2 through 1 Kelvin are in the ratio, and it is given that R1 is 1.5 times R2, right? Now we'll write the expression for delta Q, that means change in heat. It is equal to M into S into delta T, where M is the mass, S is the specific heat, and delta T is the change in temperature. Okay. Now here radii of spheres are given. So to use them, we will use mass in terms of volume. Okay. So mass by volume is equal to density. So mass will be equal to volume into density. Okay. And we know that volume of a sphere is equal to 4 by 3 pi r cube. So in place of mass, we can write 4 by 3 pi r cube into density, right? So let's put this value here. 4 by 3 pi r cube into rho, that means density, into S into delta T. So we can say that delta Q is proportional to cube of the radius of sphere. Okay, that means delta Q1 by delta Q2 will be equal to R1 by R2 cube. Okay, and it is given here that R1 is 1.5 times R2. So in place of R1, we'll write 1.5 R2 divided by R2 and cube. So R2 will be cancelled. So this ratio will be equal to cube of 1.5, right? So it will be equal to, and here we have to write the answer in fraction, right? Because all the options are given in fraction. So let's convert it into fraction. It will be equal to 15 divided by 10. That means 3 by 2 cube. Okay, so the cube of 3 will be 27 and the cube of 2 will be 8. So the correct answer will be 27 by 8. That means option D will be the correct answer. Question number 30 is from the chapter Semiconductor Electronics, and here we have to find the correct truth table for the given logic circuit. Okay, so we can see that two inputs A and B are passing through NOT gates first. Okay, so after passing through this NOT gate, A will become A bar. Similarly, after passing through this NOT gate, B will become B bar. Okay, and this is the NOR gate. So the inputs for NOR gate are A bar and B bar. So what will be the output? Y. It will be equal to whole bar of A bar plus B bar, right? Now, on applying De Morgan's law, we can write bar of A bar dot bar of B bar, isn't it? And we know that bar of A bar will be equal to A and bar of B bar will be equal to B. So this is the output for AND gate, isn't it? Now, let's try to find out which option gives the output for AND gate. We know that in AND gate, both the inputs should be 1 if we want an output 1. Okay. So in the first option, you can see here we are getting output 1 even though only one input is 1. Okay. So this cannot be the correct answer. Now let's have a look at other options as well. In the second option, again we are getting output 1 even if one of the inputs is not 1. Okay, so this cannot be the correct answer. Now let's move to the other options here. In the third one, again both the inputs are 1, still we are not getting an output 1. So again this is also not true. In the last one we can see that both the inputs are 1, then output is also 1. Okay, so this is the correct answer. Question number 31 is from the chapter Semiconductor Electronics, and the question is, for transistor action, which of the following statements is correct? First statement is base, emitter and collector regions should have same size. Okay, so let me draw the figure of a transistor. If this is a transistor, this is the emitter region, this is the base region, and this is the collector region. Then can you determine the length profile of this? See, as clearly visible from here, the length for collector region is maximum, then length for emitter region, and then length for base region is minimum, right? So these are not of same size. Therefore, the first statement will be incorrect. Okay. Now we come to the second statement. It says both emitter junction as well as the collector junction are forward bias. Again, this is not true because here the base emitter junction is forward bias. So this is forward bias, whereas base collector region is reverse bias. Okay. So these are not same. That means option B will also be incorrect. Okay. Now we come to the third option. It says the base region must be very thin and lightly doped. Yes, this is true, as clearly visible in the figure. This is very thin. Also, it is lightly doped. Okay, so this is the correct statement. Now, if we talk about the doping profile, that means which regions are doped highly and which are doped lightly, then the doping profile is maximum for emitter, then collector, and then base. So it is least for base region. That means base region is very lightly doped. Got it? Now we come to the last statement. It says base, emitter and collector regions should have same doping concentration. So just now we saw the doping profile. So these are not same, right? So this is also incorrect. That means only option C is correct. Question number 32 is from the chapter Waves, and the question is, in a guitar, two strings A and B made of same material are slightly out of tune and produce beats of frequency 6 Hz. When tension in B is slightly decreased, the beat frequency increases to 7 Hz. If the frequency of A is 530 Hz, then the original frequency of B will be. That means FA is given as 530 Hz and we have to find FB, right? Now we know that beat frequency is the difference in two frequencies. So here it will be the difference of frequencies of A and B. Okay, it is given as 6 Hertz. So this is FA minus FB or FB minus FA, because we don't know which one is greater, isn't it? Now here it is given that when tension in B is slightly decreased, then the beat frequency increases to 7 Hz. Okay, suppose on decreasing FB, it becomes FB dash. Okay, so it is given that the new difference of FA and FB dash is increased to 7 Hz. So in which of these two cases the value will increase on decreasing FB? In the first one, right? That means FA is greater than FB. Okay, so we can say that FA is greater than FB. Okay, so now we can write that FA minus FB is equal to 6 Hertz. FA is given in the question. It is equal to 530 Hertz minus FB will be equal to 6 Hertz. So we have to find FB, right? So it will be equal to 530 minus 6 Hertz. That means 524 Hertz. So option A will be the correct answer. Question number 33 is from the chapter Electrostatic Potential and Capacitance, and the question is, a short electric dipole has a dipole moment of 16 into 10 to the power minus 9 centimeter. The electric potential due to the dipole at a point at a distance of 0.6 meter from the center of dipole situated on a line making an angle of 60 degree with the dipole axis is, okay, and the value of 1 by 4 pi epsilon naught is given. Now, how can we find the electric potential? It is equal to Kp cos theta divided by r square. So K in this case is a constant that is equal to 1 by 4 pi epsilon naught. So its value is already given in the question. It is equal to 9 into 10 to the power 9. Okay. So let's put the value of K here. 9 into 10 to the power 9. Now, P is the dipole moment. So dipole moment is also given in the question. It is equal to 16 into 10 to the power minus 9 centimeter, right? So we'll write 16 into 10 to the power minus 19, and then we have cos theta. So theta is the angle which is mentioned as 60 degree. So cos 60 degree, right? And here r is the distance of the point from the center of the dipole, that is given as 0.6 meter. So here we have to find out the square of r, that means square of 0.6 meter. Okay. So 9 into 10 to the power 9 into 16 into 10 to the power minus 9. Actually, these minus 9 and 9 will be cancelled, right? Cos 60 degree is equal to half. And then we have square of 0.6, that means 0.36. So on solving this, we'll get 200, and the unit for potential will be volt. So the correct answer will be 200 volt. That means option A will be the correct answer. Question number 34 is from the chapter Gravitation, and the question is, a body weighs 72 Newton on the surface of the earth. What is the gravitational force on it at a height equal to half the radius of the earth? That means height is equal to r by 2, right? Now, the weight of the body at a height h will be equal to the weight of the body at the surface of the earth divided by 1 plus h by r whole square. Okay, so this mgh is the gravitational force which is asked in the question. Okay, so we can write fg here. Okay, now mg naught, that means weight at the surface of the earth, is given as 72 newton. So we'll put 72 newton here. Then here we have to write 1 plus h by r. So what will be the value of 1 plus h by r? See, 1 plus h is r by 2, right? So that means 1 plus r by 2 divided by r, isn't it? So it can be written as 1 plus r by 2r whole square. So r cancelled, that means it will be 1 plus 1 by 2 whole square, or you can say 3 by 2 square. Okay, so in place of this denominator, we'll write 3 by 2 whole square. Okay. Now on solving this, we'll get 4 by 9 into 72. So it will be equal to 32, and the unit will be Newton. So the correct option will be option A. Question number 35 is from the chapter Current Electricity, and the question is, which of the following graph represents the variation of resistivity with temperature for copper? So copper is a metal, that means it is a conductor, right? So for conductor, the variation of resistivity can be represented like this. Rho naught, that means initial resistivity, 1 plus alpha delta T, that means T minus T naught. So if we open the bracket, we'll get rho naught 1 plus alpha T minus alpha T naught. So we can say that as the temperature will increase, the resistivity will also increase, right? So let's write it down. As temperature increases, resistivity also increases. So option A cannot be the correct answer because here the resistivity is decreasing with temperature, right? So this is not correct option. In option B, the resistivity is increasing, but we'll have a look at other options as well. In option C, again it is decreasing, so not possible. In option D, again the resistivity is increasing. So either B or D can be the correct answer. So to determine which one of them is correct, we should know that at lower temperature, that means at temperature below 0 degrees Celsius, the graph deviates from a straight line. Okay, deviates from a straight line. That means the graph is not going to be a straight line. So option D will also be incorrect. Only option B will be the correct answer. Okay. Question number 36 is again from electrostatic potential and capacitance, and the question is, in a certain region of space with volume 0.2 meter cube, the electric potential is found to be 5 volt throughout. The magnitude of electric field in this region is, okay, so we know that electric field is equal to minus dV by dr. That means change in potential with respect to distance. Okay, so here it is given that the potential is 5 volt throughout. That means potential is not changing. So the change in potential is 0. So electric field will also be 0. Okay, so option D will be the correct answer. Question number 37 is from kinetic theory, and the question is the average thermal energy for a monoatomic gas is. Okay, so Kb is the Boltzmann constant and T is absolute temperature. So what is the formula for average thermal energy? It is equal to degree of freedom into half kT, where K is the Boltzmann constant, therefore it is also written as Kb, and T is the absolute temperature. So degree of freedom for a monoatomic gas is 3. So it will be 3 into 1 by 2 Kb T. So it will be 3 by 2 Kb into T. So out of the given options, option A will be the correct answer. Question number 38 is from the chapter Systems of Particles and Rotational Motion, and the question is find the torque about the origin when a force of 3 j cap acts on a particle whose position vector is 2 k cap meter. Okay, so we know that torque is equal to vector r cross vector f, where vector r is the position vector and f is the force. Okay, so it is given that the position vector is 2 k cap meter and force is 3 j cap, right? So 2 into 3 will be 6. Now what will be k cap into j cap? See, I cap cross j cap is equal to k cap. Then j cap cross k cap will be I cap, and then k cap cross I cap will be equal to j cap. Okay, now if we reverse the positions, then the same will be in minus. Okay, so here you can see j cap cross k cap is equal to I cap, but here we have to multiply k cap into j cap. Okay, that means the same will be in minus, so here we will have minus I cap. Okay, so the quantity will be minus 6 I cap and the unit will be Newton meter. So the correct answer will be option B, minus 6 I cap Newton meter. Question number 39 is from the chapter Dual Nature of Radiation and Matter, and the question is light of frequency 1.5 times the threshold frequency is incident on a photosensitive material. What will be the photoelectric current if the frequency is halved and intensity is doubled? Okay, so if suppose f is the frequency of light and f naught is the threshold frequency, then it is given that f is 1.5 times f naught. Okay, so we can say that kinetic energy, maximum kinetic energy of the electron will be equal to hf minus hf naught. So we can write it hf minus f naught. And what is f? It is 1.5 times f naught. So it will be 1.5 f naught minus f naught. So this will give us a positive value, right? So this will be possible. Now in second case, what happens? The frequency is halved. So the halved frequency, that means f by 2 will be equal to what? 1.5 f naught by 2. Okay, so it will become 0.75 f naught. So 0.75 f naught is less than f naught, right? So whenever the frequency becomes lower than the threshold frequency, then no electron will be emitted. Okay, and when no electron is emitted, then the current will be 0. Okay, therefore, option C will be the correct answer. Question number 40 is from the chapter Moving Charges and Magnetism. And the question is a long solenoid of 50 centimeter length having 100 turns carries a current of 2.5 ampere. The magnetic field at the center of the solenoid is. So we have to find out the magnetic field B. Okay, mu naught is given. Then length is given as 50 centimeter. That means it will be 50 into 10 to the power minus 2 meter, right? And total number of turns is 100. Current is given as 2.5 ampere. Now the magnetic field at the center of the solenoid is given as mu naught into n into I. Okay, so mu naught is what? It is given in the question 4 pi into 10 to the power minus 7. So 4 pi into 10 to the power minus 7. Then small n is the number of turns per unit length. So the total number of turns is given as 100 and length is given as 50 centimeter. That means 50 into 10 to the power minus 2 meter. So what will be the number of turns per meter? It will come out to be 200 turns per meter. Okay. So small n will be 200. Now I is the current. So current is given as 2.5 ampere. Now if we solve this, we'll get 6.28 into 10 to the power minus 4, and the unit of magnetic field will be Tesla. Okay. So which option will be correct? Option D will be the correct answer. Question number 41 is from the chapter Wave Optics, and the question is the Brewster's angle IB for an interface should be. Okay, so here we will apply the Brewster's law. According to the Brewster's law, tan IB is equal to the refractive index of a medium. Okay, mu is the refractive index. Now we know that the refractive index of a medium is always greater than 1. Okay. So we can say that tan IB is greater than 1. Okay. Now for what value of IB, tan IB will be greater than 1? See, we know that tan 30 degrees less than 1. Tan 45 degree is equal to 1, right? And tan 90 degree is equal to infinity. So the value should be between tan 45 degree to tan 90 degree. Okay. So IB should be more than 45 degree and less than 90 degree. Okay. Then tan IB will be greater than 1. Okay. So option B will be the correct answer. Question number 42 is from dual nature of radiation and matter, and the question is an electron is accelerated from rest through a potential difference of V volt. If the de Broglie wavelength of the electron is 1.227 into 10 to the power minus 2 nanometer, then the potential difference is, okay. So we can write the de Broglie wavelength in terms of potential difference as 12.27 by root V angstrom, and root V is the root of potential difference. So we have to find out the potential difference. So root V equals to 12.27 divided by de Broglie wavelength, and the unit will be angstrom. Okay. So we know that 1 angstrom is equal to 10 to the power minus 10 meter, right? So here we'll put 12.27 into 10 to the power minus 10. Okay. And in place of lambda, we know it is given as 1.227 into 10 to the power minus 2 nanometer, and 1 nanometer is equal to 10 to the power minus 9 meter. So in meter we can write 1.227 into 10 to the power minus 2 into 10 to the power minus 9 meter. Okay, so this will become 10 to the power minus 11. So 1.227 into 10 to the power minus 11 meter. Okay, so here in place of de Broglie wavelength we'll write 1.227 into 10 to the power minus 11. Okay. On solving this, we'll get 10 to the power 2. So this is the value of root V. So what will be the value of V? It will be the square of 10 to the power 2. That means 10 to the power 4. And the unit for potential difference will be volts. So the answer will be 10 to the power 4 volts. That means option C will be the correct answer. Question number 43 is from the chapter Units and Dimensions, and the question is taking into account of the significant figures, what is the value of 9.99 meter minus 0.0099 meter? Okay, so let's find the difference first. 9.99 minus 0.0099. Okay, so we'll put here two zeros. Now let's subtract. 10 minus 9 will be 1. Here we'll have 9. So 9 minus 9 will be 0. This has become 8. So 8 minus 0 will be 8. Then 9 minus 0 will be 9. Again 9 minus 0, 9. Okay. So this is the difference. Now we have to take into account the significant figures. So we should know that in case of subtraction, answer should be reported to least number of decimal places. Okay. What do we mean by least number of decimal places? See, look at the question first. Here we have two numbers. In the first number, we have 2 digits after the decimal. Okay, 2 digits. Whereas in the second number, we have 4 digits after decimal. Okay, so the minimum is 2. That means we will put 2 digits after decimal in the answer as well. Okay, so the answer will be 9.98. Okay, and the unit is meter, right? So option A will be the correct answer. Question number 44 is again from units and dimensions, and the question is, a screw gauge has least count of 0.01 millimeter and there are 50 divisions in its circular scale. Okay, so the pitch of the screw gauge is, so we have to find out the pitch. What is the formula for least count? Least count is equal to pitch divided by number of divisions on the circular scale, right? On circular scale. Now, least count is given as 0.01 millimeter. Pitch is unknown. We have to find out. Then number of divisions on the circular scale is also mentioned. It is 50 divisions. Okay. So 50. Then what will be the pitch? It will be equal to 0.01 millimeter into 50. So it will come out to be 0.5 millimeter, right? So option B will be the correct answer. Question number 45 is from the chapter Oscillations, and the question is, the phase difference between displacement and acceleration of a particle in a simple harmonic motion is. Okay, so what is the equation for displacement y? It is equal to a sine omega t. Okay, so what will be the velocity? Velocity v will be equal to dy by dt. That means differentiation of displacement. So we have to differentiate a sine omega t. Okay. So on differentiating this, we will get a omega cos omega t. Right. So this is the velocity. Now we have to find the acceleration. Now to get the acceleration, we'll have to differentiate the velocity. Okay, that means dv by dt. So let's differentiate it. Differentiation of a omega cos omega t. Now what will we get here? We'll get minus a omega square sine omega t. Now, so to change this minus sign to plus, we can write a omega square sine omega t plus pi. Okay, that means 180 degree. So here we can see, on comparing the displacement y with acceleration a omega square sine omega t plus pi, it is clear that the difference in phase is pi. Okay, here we have sine omega t and here we have omega t plus pi. So the difference is pi. That means which option will be correct? Option D will be the correct answer. Okay, so here we complete the physics questions from this paper. I hope the session was helpful to you. Keep learning, keep scoring high. For any doubt related to papers, join our Telegram channel. Link is given in description. Also, do subscribe our YouTube channel for more such informative videos. Thank you.